Have you ever just stopped and wondered if the universe was, well, somehow made for us? It's this massive mind-bending question, you know? It sits right where physics and philosophy crash into each other. Today, we're going to dive into one of the most provocative ideas in all of cosmology that actually tries to answer it, the anthropic principle.
You see, at the very heart of all this is a really fundamental mystery. We look around and we see order everywhere. Gravity does its thing, stars burn the way they're supposed to, planets stay in their orbits. But why? What actually compels the universe to follow these incredibly precise mathematical rules? Why isn't it all just a chaotic, unpredictable mess? It's a question that's kept thinkers up at night for centuries, and it really sets the stage for everything we're about to talk about.
Because when you really start to look closely, the whole puzzle just gets deeper. The conditions, the physical constants, the actual laws of our universe, they all seem perfectly, almost impossibly fine-tuned for life to even exist. It's like the cosmos is a custom-made suit, tailored right down to the last atom just for us. So the big question is this all just one gigantic coincidence?
Okay, so to really get a grip on the anthropic principle, first we have to appreciate what scientists call the fine-tuning problem. You might have also heard it called the cosmic Goldilocks problem. The idea is that for life to exist, the conditions of our universe couldn't be too hot, couldn't be too cold, they had to be just right. And the degree of just right is honestly staggering.
Let's start with a big one, the cosmological constant. That's basically the energy of empty space. Now, our best theories predict that this number should be absolutely enormous, but instead, the value we've actually measured is ridiculously close to zero. We're talking 10 to the power of negative 120. That's a decimal point followed by 119 zeros and then a 1. It is an unbelievably, absurdly tiny number.
Nobel Prize winner Steven Weinberg famously called this difference between theory and reality the worst prediction in physics. And the implication here is just staggering. If that tiny, tiny value were even a little bit larger, the universe would have expanded so fast that stars and galaxies could never have formed. And, well, no stars, no planets, no us.
And it's not just that one number. The fundamental forces of nature are also balanced on a razor's edge. Tweak the strong or weak nuclear forces just a tiny bit, and boom, the early universe would have basically cooked all of its hydrogen into helium. Without hydrogen, you get no water, you get no stable, long-lived stars like our sun, and you definitely don't get any of the building blocks for life as we know it.
So how in the world do you explain this incredible fine-tuning? Well, this is where the anthropic principle finally makes its entrance. It's a really radical and, let's be honest, deeply controversial idea that tries to solve the puzzle by completely flipping our perspective on the whole question.
Okay, so in its simplest form, the principle argues that of course we see a universe that's friendly to life. It's what's called an observation selection effect. Think about it. If the universe's properties were any different, if those constants were tweaked even slightly, we just wouldn't exist to be here scratching our heads about it. So it's not that the universe was made for us, but that we could only have shown up in a universe like this one.
But you know, it's not that simple. The anthropic principle isn't just one single idea. It actually splits into two main versions, a weak one and a strong one. And they have very, very different implications for, well, the entire nature of reality. The astrophysicist who coined the term, Brandon Carter, he laid out these two flavors. The weak anthropic principle, or WAP, is the less controversial one. It pretty much just says our location in space and time is special. But then you have the strong anthropic principle, or SAP, which makes a much, much bigger claim, that the universe's fundamental parameters must be the way they are so that observers like us can exist. So here's the real difference, right? The weak principle is all about our location. Of course, we live on a planet that can support life. In a golden age for stars, we couldn't exist anywhere else or at any other time. Easy enough. But the strong principle, that says the very rules of the game, the fundamental laws of physics themselves, are special. And that is a much, much more radical idea.
So if the laws of physics themselves are special, how do you explain that scientifically without, invoking a creator? Well, for a lot of physicists, the strong anthropic principle leads you down a path to a pretty wild conclusion, the multiverse.
The reasoning kind of goes like this. Look, if our universe is the only one that exists, then its life-friendly laws are just a lucky, unexplained fluke, a brute fact. But if you want a scientific explanation for it, you need to have other possibilities to compare it to. And that line of thought leads you to the idea of a multiverse, a huge, maybe infinite collection of universes, each with slightly different physical laws. Suddenly, our universe isn't so special. It's just one of the rare ones where somebody can actually be around to notice.
Now, as you can probably guess, not everyone is sold on this. The anthropic principle, especially its strong version, and the whole multiverse idea it points to, has faced some really powerful pushback from scientists and philosophers who question if it even counts as science at all.
The biologist Stephen Jay Gould came up with this brilliant analogy that really gets to the core of the criticism. He said that arguing the universe is fine-tuned for us is kind of like saying sausages were designed to be long and narrow, specifically to fit into hot dog buns. It completely gets cause and effect backward. Life adapted to the universe, right? Not the other way around.
And the criticisms are pretty potent. Some argue it's just a tautology, a fancy circular way of saying if things were different, they'd be different, which, explains nothing. Others say it's unfalsifiable. How could you ever design an experiment to test for a universe where observers can't exist? And maybe the biggest fear is that it could actually stop science in its tracks, discouraging us from searching for a deeper theory of everything by just letting us say, well, it just had to be this way.
So where does all of this leave us? Is the anthropic principle just a dead end? Well, not necessarily. Whether you find it brilliant or infuriating, its greatest value might just be as a tool that forces us to confront our own biases as observers and to think really, really deeply about our place in the cosmos. The physicist Paul Davies did a great job summarizing the main options we have on the table for explaining our seemingly fine-tuned universe. The anthropic principle is really what powers that multiverse explanation. But as you can see, it's just one of several mind-bending possibilities, and they range from pure chance to some deeper undiscovered theory, and even to ideas that are way outside of conventional science.
In the end, the anthropic principle doesn't really give us a final, neat answer. What it does is leave us with maybe the most profound question there is. Are we the result of a cosmic lottery win? A predestined outcome baked into the laws of physics? Or is our existence just a trick of perspective, the only story that could ever be told, simply because we're the ones here to tell it?